The next thing we're going to talk about is tip, basic field setup. Why do you want to use one tip versus another tip? What are your height parameters when you're sitting up because you're hooded? You certainly don't want to drag this in the ground. That's going to cause some problems for you. It's going to wear the pods prematurely. So when we're going to go out into the field, and we're absolutely going to set this up, and today we're not going to be able to spray, and we're not in the field, so it's going to be a little more difficult to show how you would set this up, but we're certainly going to talk about it. First thing that you need to know with regards to a setup is what your output parameters are. How fast am I going to drive? How many gallons per acre do I want to put up? All right. How much pressure am I looking for? Because all three of those things are interconnected and probably as crucial to your setup as having, the technology is going to protect the environment. Your setup, similar to a bar, is going to have to be set up appropriately for the crop that you're spraying. If you are trying to atomize or have a high atomization, which is the smallest droplet possible, as many small droplets as you can, a couple things are going to happen. If you use a coarse tip, you're going to get a big droplet. So if you're trying to increase your atomization, you're going to have to drop your nozzle or tip size down. You want to shrink that down. Now, the farther down you go, the less output you're going to get. I can only get out of a number one or a number two tip, I can only get so many gallons per acre out of that, even if my pressure spiked to 150 PSI. It's going to be blasting as hard as it can. It's pushing everything it possibly can, but only so much can come out that hole. All right? Now you're going to have massive atomization. You're going to basically create a mist. It's not going to be a droplet anymore. It's going to be a fog. What happens to a light droplet? A big droplet's heavy and wants to fall to the ground. Simple and easy. You atomize that, and the smaller you atomize it, the smaller that droplet gets, the lighter it gets, the more of a fog it creates, the more susceptible to drift you are, right? So even though we've got drift control, if you put a number one on this and you run that up and you're saying, okay, listen, I've got a number one tip and I'm going to try to put 200 gallons per acre out of that number one. First of all, you're not getting 200 gallons out of it. But the Raven's just going to blast at you the whole time telling you you're not getting your rates, you're not getting your rates. You're atomizing, and you're going to see some drift. You're going to increase. So the smaller the tip, the higher percentage drift, right? So you got to pay attention to what am I really trying to achieve here. Do curtains at that point make sense if I'm really trying to atomize? What we see most guys trying to do is increase pressure by reducing the tip a little bit because they're trying to drive the material into the crop. We don't have to spend as much time worrying about driving the product into the crop as deep because that's not what's moving the plant now. The air is what's moving the crop. All right, so in general cases, if you look at the strawberry industry, they're using extremely high pressures and high rates of output. They're literally trying to blast. And what was one that you had the other day, Ramon? They kept saying more pressure, more pressure, more pressure, more pressure. And they wanted to reduce the tips and they wanted to do different things because they're still trying to use the technology as a standard bar sprayer because that's what they understand. So they're trying to cram everything they can out of that small nozzle and increase that pressure to drive it down into the plant as far as they can. You don't necessarily have to do that with the GenZ sprayer, but you do have to find a balance. All right. These are number fours. It's about a mid-range tip, 50, 70 gallons per acre, up to 100 gallons per acre. Not bad. If you're going to run 50 gallons per acre, you're going to watch your pressure drop. Because again, the bigger the orifice, the lower the pressure is required to drive that amount of gallons out of it. Now, you can have an orifice that's so big that you're literally just going to drift. You take a number 8 and you tell it you want 10 gallons of output. That's like putting a drop of water in a 1 gallon or 1 inch hose. It's just going to trickle out. You're going to have no backing pressure for it because it's saying, hey, I don't need much pressure to get that gallon output out. So what I would recommend doing is, you're familiar with T-Jet? Everybody's familiar with T-Jet? TJet has a great catalog that shows you every tip, every nozzle orifice. Read that, understand that, and understand how the relationship of pressure and output work. Now we're going to throw another one in there. We're going to add speed. Dang it. Now I've screwed my whole formula up. Because now I'm going to go at a rate of speed, which is going to say, hey, you either need more or less based on the speed that you're going. If I'm not going anywhere and I'm saying I want 20 gallons or 10 gallons of output and I've got this big nozzle and I flip that on, you literally are going to get a trickle. Now, I set my speed parameter up and I want to go 25 miles an hour. As you're going 25 miles an hour, all of a sudden it's going to say, hey, I'm going really fast. I'm going to have to put, I'm going to have to put something behind here to get that output out. But it's not going to have 100 PSI because it's still such a big orifice, right? And such a low gallons per minute or acre output. But I am driving at a speed now, so it may back that with 25 or 30 or 40 pounds of pressure. 40 pounds of pressure going through this nozzle is going to spit. It's not going to spray. So you're just going to have, it's going to look more like a sprinkler head at that point in time. So, guy says, that's not going to be very effective, so I'm going to drop that thing down, and instead of dropping from an 8 to a 6 or an 8 to a 4, he goes all the way down to a 2. Now he's saying, I want to drive 25 miles an hour with the number 2 tip, and then he can't understand why he's not getting the results that he needs, or the output's out. His Raven's beeping at it, and you're not achieving your gallons per minute because you can't force that much through it again. So what you have to do is consider your speed profile, your gallons per acre output in relationship to the nozzle. None of that is any different than a bar spreader. That's where this technology is designed to mirror the bar spreader. Everybody understands in the field those formulas. These guys know pretty much inherently, because they're doing it every day, what tips I need to use, what speeds we're going to be driving, and what we're trying to achieve here with our outputs. In strawberries, you're going to go much slower than you do in vegetables. You are going to run into customers, however, that say, oh no, we want to drive 12 miles an hour. I've got 2,000 acres, man. I got to cover acres. That's not going to work for me. So put a tip that's this big a hole in there and let's go. You're going to outdrive the technology. You're going to drive faster than the amount of air that's coming out there. You're going to exceed the crop before it really does anything, and it doesn't have a chance to actually blow the crop. It's just going to, it's just going to give it a little whipping, and you're already beyond it. You're not allowing the technology to work. This machine is designed on vegetables in the 6 to 8 mile an hour range. 6 mile an hour range is optimal. 8 mile an hour range for performance, absolutely doable with great results. What speeds do you guys run?
9, 10 miles an hour.
Okay, so they're running 9, 10 miles an hour. They're getting a little bit faster. No 12? Good. Yeah. Don't tell me that you're doing 12. If you're doing 12 and you're getting results, fantastic. We have a customer in the desert that they literally just run lights out. And they've got a bar sprayer. And in that bar sprayer, at 12 miles an hour, it's a light unit, and that thing's doing this in the field. And I'm like, wow, really, you're effective. That you're going. I've got 2,000 acres, man. I can't stop. I got to go. And I'm like, but you're, at 12 miles an hour, every time that thing lifts up, he's skipping 12 to 15 feet. And so he's got these big circles in his field that are brown, that the bugs are infected. And right, these are not birds. They have wings, but they're not meant to fly. That thing was flying. But he's got this big problem with these brown circles all over his field where he's missing, he's skipping. And he comes back and he's like, why is that happening? Like, I wonder why that's happening. You guys, it's not making any sense. Slow down. Increase your effectiveness. $80 in the middle. So the last phone call, I'll turn my phone off, has to pay the entire kitty. So we tried to talk to them about the difference in speed, the advantages of slowing down a little bit, and they said that's fine and that's great, and I'm willing to sacrifice the brown circles, I guess, in my field because I only have a spray crew that's this big, and I've got to cover all 2,000 acres, or else that entire field out there is going to look like this. Well, okay, that's their choice. Technology is only good to its highest limits. After that, if you're outperforming the technology, all bets are off. So 6 to 8 miles an hour is where we recommend. You guys drive 9, 10, and you're getting good results, then fantastic. They found a sweet spot that works for them, but we don't go into a conversation with our growers and saying that, you know, start out at the 9 or 10. Let's start out at the 6. Let's get used to the technology and increase your speeds as you need to increase your speeds. Understand labor's, you know, an issue, and we want to make sure we address it, but again, we can't out or overuse the technology. With regards to the tips, the outputs, feeds and speeds, any questions? Where are you going to go get your recommended information on your nozzles? TJ. We use TJ nozzles as a standard component. They're readily available. You can change it when you're going to go do demos. Understand the crop that you're going to be spraying. Understand what speeds they normally run. Understand their normal outputs, because that's really what you're going to want to show them. They're going to be basing everything off of what they know, and they're going to look at this. The other thing I would recommend doing is do side-by-sides. If you're going to go do a demonstration, bring the technology that they're currently using out there, because I guarantee you in their mind, they're getting 100% effective coverage, and that means every leaf is perfectly coated, top and bottom, all the way down. The root base is covered, the ground's wet around it slightly, it's perfect. Now, if you get the bar out there during that demonstration and you run this against the bar, they start looking at it and going, oh, that didn't work so well. But what's going on with our bar? Spray crew, what's going on? Well, that's a normal spray pattern. That's what it's getting every day. They'll look at both of them and start doing an actual comparison to what's more effective and what's not. If you don't have a side-by-side, and in many cases you probably won't, you're going to have to overcome that objection. Because again, in everybody's mind, and spray is being done at night, and the guy you're talking to is probably a foreman, a ranch manager, maybe an owner, he's probably not the guy that's out there every single night talking about or looking at his fields. So again, he's just being told, yeah, I know, boss, we got good 100% coverage. Right, fantastic. Well, so in his mind, it's 100%. So you do have to overcome that.